Hello, everybody, and welcome to the stoichiometry review session. Before we get started on the review problems, just to let you know, the format of your test is you're going to have 7 multiple choice questions, and then you are going to have 5 calculations. Now, of those calculations, several of them are multi-part, so be prepared for that. So let's just dive right in and go on ahead with review problem number 1. A student performs the following reaction, and here I have given you a balanced equation. What is the theoretical yield of sodium chloride when 33 grams of magnesium chloride reacts with excess sodium? So a couple of things. Please remember that every stoichiometry problem absolutely must start with a balanced equation. Now, sometimes we will give you the balanced equation, sometimes we won't, and you will need to write the reactants, products, and balance it. But it absolutely must be here. All right, next up. When I use the phrase theoretical yield, that means ideally what should happen. This is what we calculate on paper as opposed to what a student or you would get in a laboratory. All right. So I have 33 grams of magnesium chloride reacting with excess sodium. Remember, excess means you have plenty of it. So that's not going to be the one that runs out. So we're just interested in this 33 grams of magnesium chloride, MgCl2. And I want to know how much sodium chloride, so my final answer, grams of NaCl, will be produced. Anytime you go from one substance to another, you must have a mole-to-mole ratio. We're going to get that mole-to-mole ratio from your balanced equation. So our first step is going to be to convert from grams to moles. 1 mole of MgCl2. You're going to look at your periodic tables, find the molar mass of magnesium chloride, so 2 chlorines and 1 magnesium, and you're going to find that that's 95.3 grams. Then you're going to do your mole to mole. I want to get rid of moles of magnesium chloride, and I want to go to moles of what I'm looking for, which is sodium chloride. All right, I go up. Magnesium chloride has an assumed coefficient of 1, so that is 1. Sodium chloride has a coefficient of 2, and that is your mole-to-mole ratio. All right, I'm now going to go from moles to grams of sodium chloride. 1 mole of NaCl, remember you always want them canceling out, has a molar mass, and I got this from the periodic table, of 58.5 grams. Okay. You're then going to multiply everything on the top, divide it by the product of the bottom, and you get here about 41 grams of sodium chloride. Don't worry too much about the final rounding, just be reasonable with the numbers that we give you in the problem. All right, let's take a look at number 2. 15 grams of oxygen gas are mixed with 20 grams of sodium. What mass of product should be produced? Well, as we mentioned before, first thing is to write your balanced equation. So I have oxygen gas, which is O2, and that is reacting with sodium. All right, this is a synthesis reaction, so sodium and oxygen are going to go together. That's an ionic compound. Sodium has a charge of +1. Oxygen has a charge of -2, so it's going to be Na2O. Metal always comes first in an ionic compound. I then need to go on ahead and balance this. I have 2 oxygens here. I only have 1 here, so I'm going to go ahead and put a 2. All right, and then I'm going to put a 4 to balance out those sodiums. Now, in this problem, 15 grams of oxygen and 20 grams of sodium. So I have an amount of oxygen and I have an amount of sodium. That means this is a limiting reactant problem. I'm going to have to do 2 factor label problems. So I'm going to start out with my 15.0 grams of O2 and figure out, they want to know mass of product, figure out the grams of Na2O that are produced. I'm going to do a separate factor label with my 20.0 grams of sodium and also figure out how much sodium oxide can be produced from that. All right, I'm going to go on ahead. 1 mole of O2 has a molar mass of 32.0 grams. 1 oxygen, 16, 2 of them's 32. Mole to mole ratio, I have 1 mole of O2 for my balanced equation for every 2 moles of Na2O. And then finally, 1 mole of sodium oxide has a molar mass of 62.0 grams. Okay. All right, I'll put it in my calculator in just a moment. I'm now going to set up my other reactant. So I have 1 mole of sodium is 23.0 grams, again from the periodic table. Then you have 4 moles of sodium for my balanced equation for every 2 moles of Na2O. And 1 mole of that is still 62.0 grams of Na2O. All right, at this point, I'd go ahead and put the numbers into the calculator. Starting up here, 15 times 2 times 62 divided by 32, which is times 1 times 1, so just 32. And that's going to give you about 58.1 grams. Down here, if I go 20 times 2 times 62 divided by the product of 23 times 4, I get about 27.0 grams. Your answer is the smaller amount, because once you have produced the smaller amount, in this case your sodium runs out. If I were to have asked you what is your limiting reactant, it would be your sodium. All right, let's take a look at number 3. Number 3, magnesium reacts with hydrochloric acid in a single displacement reaction. You react 12 grams of magnesium and excess HCl. You retrieve 0.88 grams of hydrogen gas. What is your percent yield? Again, first thing we're always going to do is write out our balanced equation. So magnesium is reacting with HCl. All right, magnesium is going to take the place of that hydrogen, giving you MgCl2, because it's plus 2 minus 1. And then remembering that hydrogen gas is a diatomic, so that is H2 right there. I then need to balance, and all I need is a 2. All right. So here, you react 12 grams of magnesium. So you have 12.0 grams of magnesium. You retrieve 0.88 grams of H2 gas. So this is you. This is what you did. So you're going to use this. This is your lab value. You won't use that till the end. You want to figure out theoretically, starting with 12 grams of magnesium, how many grams of H2 you should produce. So let's go on ahead and do that. 1 mole of magnesium from your periodic table is 24.3 grams. For every 1 mole of magnesium, this is my mole to mole, 1 mole of magnesium, I produce 1 mole of H2. Even though this is the same number, you still have to include it in the problem. 1 mole of H2 is 2.0 grams. Okay. Once you put all of this into your calculators, you get 0.99 grams of H2. This is your theoretical yield. All right. I've asked for your percent yield. You're going to take your lab value, 0.88, divide it by your theoretical, 0.99. Oh, sorry, I'm off screen. And multiply that by 100. So again, that is your lab. This is your theoretical. All right. And when I do that, I get about 88.9% yield, okay, as my final answer. All right. Okay, let's take a look at number 4. Number 4. When a student combines 36 grams of chlorine with excess sodium, the reaction produces table salt. The teacher anticipates a 90% yield for this reaction. What mass of salt must the student produce to achieve this yield? Again, first thing I'm going to do is write that balanced equation. So the student is mixing sodium and chlorine gas, remembering that chlorine gas is a diatomic. They are making table salt, which is sodium chloride, NaCl, plus 1 minus 1. I'm going to then go on ahead and balance this. So I need a 2 and a 2. All right. The student combines 36 grams of chlorine and excess sodium. So excess means this is not a limiting reactant problem. I'm going to start with my 36 grams of Cl2. I want to know how many grams of NaCl that's going to give me. I'm going to go ahead and do my factor label. 1 mole of Cl2 is 71.0 grams from the periodic table. 1 mole of Cl2 from my balanced equation is going to give me 2 moles of NaCl. 1 mole of NaCl has a molar mass of 58.5 grams. I'm going to punch that in my calculator, and I get 59.3 grams of sodium chloride. Now, this is, again, the theoretical yield. This is in an ideal world, this is what you would get. The teacher doesn't expect that. She only expects you to get a 90% yield. So what do you need to do to achieve that, to reach that goal? So you're going to take 90%, and all you do is 0.09. Okay, remember, you just move the decimal place over 2 times. So 0.09 times 59.3, and that gives you 53.4 grams. And that is your final answer for this problem. All right, last one that we are going to do for our review session. All right, has you doing a whole lot of different things here. All right, so let's take a look. 25 grams of magnesium nitrate reacts with 25 grams of sodium phosphate. So right there, all right, I have an amount of each reactant. Okay, what is the theoretical yield of precipitate? What is your limiting reactant? And what mass of excess should be left over? So if we're going to start out, as we always do, writing our balanced equation. So I have magnesium nitrate, making sure my charges are all correct, okay, plus sodium phosphate. This is a double replacement reaction. Magnesium is going to go with that phosphate. So Mg3PO4 2. Magnesium's plus 2, phosphates -3. Okay. Plus sodium nitrate. I'm going to then need to balance this, so I need 3 magnesiums there. Okay. I need 2 phosphates there, and then 2 times 3, I'm going to need a 6 here. So I have my balanced equation. I need to identify my precipitate, and I'm going to look at my products. Looking at solubility rules, sodium and nitrate can never be part of a precipitate. That's rule 1 and rule 2. My precipitate is magnesium phosphate, so remember a little S there. And then we can underline it to make sure that we remember that that's what we are looking for. What is the theoretical yield? So for part A, I am going to set up a limiting reactant problem. I have 25 grams of MgNO3(2), and I have 25 grams of sodium phosphate. For each of these, I'm going to determine how many grams of magnesium phosphate should be produced. So 1 mole of magnesium nitrate. Okay, I get on the periodic table, the molar mass is 148.3 grams. I have 3 moles of this in my balanced equation. For every 1 mole of my precipitate. And then in 1 mole of magnesium phosphate, my molar mass is 262.9 grams. So if it was just up to this magnesium nitrate, I would be able to produce 14.8 grams of magnesium phosphate. But I need to check to see how much the sodium phosphate is going to give me. So again, same steps, 1 mole of Na3PO4. Molar mass from the periodic table is 164. Oh, sorry about the handwriting. All right, 0.0 grams. I have 2 moles of Na3PO4 for every 1 mole of Mg3PO4(2). And for every 1 mole, just like we have above, of magnesium phosphate is 262.9 grams, again, from that periodic table. When I go on ahead and multiply everything on the top, divide it by the product of the bottom, I get about 20.0 grams of Mg3PO4, 2. All right. So as we've stated before, when dealing with limiting reactant problems, the reactant that gives you the smaller amount of product, that is your limiting reactant, and this is going to be your theoretical yield. So this is your answer to A. Your limiting reactant, here's your answer to B, is your magnesium nitrate, the one that gave you that answer. So we've answered A, we've answered B. Now let's talk about C. What mass of excess is going to be left over? There's different ways of solving this problem. I'm going to show you the way that I like. I like to start with my theoretical yield. So I'm going to start with 14.8 grams of magnesium phosphate. And I'm going to figure out how much of my excess, because remember Na3PO4 is my excess, so I'm going for grams of Na3PO4, it took to make that amount of product. Now, this should go a little bit quicker because you have all of the masses already. 1 mole of magnesium phosphate, we already know, is 262.9 grams. And then you have 1 mole of Mg3PO4, 2. And now we're going to sodium phosphate, so that's 2 up here. All right, so that's 2 moles of Na3PO4. And then in 1 mole of sodium phosphate, you have a mass of 164 grams. All right, and that gets you 18.5 grams. Now, what does this number mean? 18.5 grams of sodium phosphate that was used. The question is, how much is left over? Well, you started with 25 grams. This is where you started. Okay, you're going to subtract 18.5 because that's how much you used. And that's going to leave you with what is left over, which in this case, 25 minus 18.5 is 6.5 grams of Na3PO4, which is your answer to C. Okay, and you're going to make sure you do your teachers a good favor and circle your answers and label them very clearly like I did here. All right, I hope this helped. Good luck on the test and have a great day. Take care. Bye-bye.